so write this down for me real quickly, gang. Be on page 805. And I'm going to ask you to do problems 53 through 60.
53 through 60?
Yep, 53 through 60. And let's go do, let's see, what is today? Tuesday. So let's go do Thursday with this, all right? So I think that's 8 problems. All right, so go ahead and take a second and get that written down there.
I can't find my planner. Where is it?
Find what, John?
My actual planner. I can't find it.
Don't worry about it now. We'll get it,
Wait, I found it.
we'll get it written down.
I found it. What day is it?
Today is Tuesday the 4th, Johnny. All right, you guys got that down?
Yep.
All right, go ahead and get started here notes-wise.
Page 805.
Yep. John, get from someone. We're gonna roll on this, okay, kiddo?
Page 805, 53.
All right. Guys, real quickly, I just want to recall some stuff here from stuff we've done in the past. Involving equations right here. Simple two-step equation, right? So help me recall how to do this, because what we want to do is take some of the processes here and apply it to what we're going to be talking about today. So Allie, help me out, kiddo.
Subtract 6 from 24.
So I want to subtract 6 from both sides, correct? All right, so good. So help me rewrite this. Where are you at now?
2x.
Equals? What's that difference there, guys? 24 minus 6. Yeah, we're about either.
All this and rabbits.
What have you guys got here? What is 24 minus 6? 18, right? So now we would simply say, you know what? We're going to take 18 and divide by 2. So if I divide 18 by 2, where am I, gang? So under equations, this was just simply x equals 9, right? So, real quickly, anytime we're looking at doing some of these like this, we want to say, well, it'd be a good idea to undo any addition or subtraction first, and then undo any multiplication, division second in a two-step equation like that. Now, recall something like this.
Where
You
is
know,
this the rule?
we've looked at stuff with parentheses like this before. What property allows us to rewrite this expression right there? What's the name of that property? Start with E. What is it, Chelsea?
Wait, what?
What property allows us to rewrite this? If I draw arrows here to multiply this out. Distributed. Okay. Obviously my hearing's getting bad. All right, so yeah, we've got to do that as well. So there's a lot of things that we want to recall from stuff that we've done in the past. This would be the same as 3x plus 18, okay, when I distribute. So we've got to keep that stuff in mind. So realistically today, guys, our goal is this. We're kind of going to go ahead and tie all these rules that we've had for equations into what it looks like for inequalities today. So on the first page of your notes, what I want to do is get started by rewriting the rules that allow us to establish what we're doing here. So set this up like so. Guys, rule 1, we've talked about this in the past. If you have any parentheses, what do you always have to get rid of first? You got to get rid of them. So the first rule I'm going to put down here is this. If you can, if it's possible, you always want to distribute. Okay? First rule there is to always, always, always distribute. Okay? Always distribute. You guys okay with that for rule 1? All right, what if I had something like this then? If I had 3x plus 7x plus 4 equaled 44, what do I have to do with the two terms that are on the same side first? Lily? I gotta combine them. So there's a shot here that I might have to combine terms on either the left side or the right side.
Sorry.
So the second rule I want you to write down again, just to remember all this, is to combine like terms.
Combine like
All right, combine like terms. And I'm going to try to squeeze this in here, each side. Combine like terms on each side. It's possible you might have to do it to the left or the right, or maybe the left and the right. So combine like terms to either the left side or the right side. And we'll look at some problems that involve all of this. You guys like my handwriting today? It's pretty nice, isn't it? All right, third step.
yes.
Third step, this was kind of the tricky one. So by the third step here, you might want to go ahead and make sure that you put some kind of a note by it that says it's kind of important. This one's pretty important right here. Okay. Step 3 is, just be careful, and I'll put a question mark by it. Okay. You guys have this first 2 rules down?
Yep.
Done both?
I do.
All right. There's been times where we looked at equations that had variables not on just one side, but on both sides. Okay. I think the way I've set you guys up with equations in the past is say, hey, I don't like this x being over here on the right side, right? So I want to move that. So first of all, the question became this: what kind of x was this? Positive or negative? It's positive. So how do I eliminate that variable from that side? I'm going to subtract that variable. So if I do it to the left, I've also got to do it to the right. Okay? And then I want to combine that variable with what we have here. So what would 3x minus a 1x on the left be? Good. 2x. And then still plus what value here? What constant? What's going to happen to the x's on the right side here? They're gone. And that's going to equal what value on the right? 6. So what I wanted to do is this: if I have variables on both sides, I want to try and get variables to just one side, right? We have a variable on the left side and the right side. I want to get variables to both sides, or one side, I'm sorry. Okay? So third rule here, I'm just going to go ahead and say, make sure you get variables to one side. Make sure we get those variables to one side.
Mr. Parsons,
Yeah.
that rule, there, it seemed like I'm trying to remember which, was a worksheet or quiz. The kids seem to have trouble on that one. There was, it was like something plus 8g was greater than like 14g was on the right or something, and they were trying to subtract that
So
g
you might
from
have
the
6.
right and move it to the left and end
Okay.
up with 0 on the right.
Yep.
And do you remember which problem I'm talking
Might
about?
be something like this
yeah,
here.
something like that. Yeah.
All right. If you subtracted 14g, the idea here was that we've talked about before and said, you know what, kids? If you get a right side, something over here, we talked about, remember when we talked about the many solutions or no solutions stuff before? And we said if everything completely drops out, what's going to happen to the 14g's on the right here, gang? They're going to cancel, okay? Now, in the process of rewriting equal expressions after some of your balancing acts, I get that these cancel right here, all right? So one thing you need to say is, well, I got to have something over here to indicate that's what we're equal to. It just doesn't cancel to invisible here. There's got to be some kind of a value that represents nothingness over here. So what value is going to take that right there? 14g minus 14g is nothing. Well, how do you represent a value of nothing? 0, don't you? So you understand why that's 0 on the right? You guys okay with that? Okay, so keep that in mind. Here you would have 8g minus 14g, which is negative 6g plus 6. Okay, you understand how I got there? So right here, if you have this situation where subtracting 14g was the process you made or the steps that you took to try and get into this situation, understand that if you have nothing left after everything cancels over here, you've got to identify that nothingness with some kind of a value. In this case, what value? 0. Okay, so what would I subtract from both sides now? 6. Mrs. Miller, is this kind of where you wanted me to go with that?
Well, yeah, because some of them I was telling him, well, you could move AG to the
Could
right.
also, yep.
Or you, if,
And it
you know,
doesn't
they
matter
really
which
want
way we
the
go.
variable on the left, just flip the
Mhm.
equation,
Yep.
you know, but they were getting stuck on that.
You have -6 divided by -6, wouldn't you? We'll look at an example. I'll make one
Yeah,
up here
no,
today that'll set up that
that was
way.
the example I wanted
Okay,
to do.
all right. So you get 1 out of that deal. But yeah, just be careful on stuff like that. That rule, and again, I shouldn't really put a question mark by it. I should probably put an exclamation point by it. This is kind of a tricky one, isn't it? Rule 3. Okay. And rule 4 and 5 we've been working on an awful lot. After you get the variables to one side, you're going to undo any addition or what?
Subtraction.
Undo any addition or subtraction. Okay. Whoa, I didn't want to do that. Get back up there, you stinker. Ah!
That's
Oh,
a
no.
screwy one, isn't it?
Huh?
That's a screwy one, isn't it?
It's not liking me today.
Yeah.
Guess, oh, lordy, lordy, look who's almost 40.
You're not. You're young. You're like 22.
John, you are the best. I love it. What's going on here, Mrs. Miller?
I don't know.
I'm having a Jay Cutler moment.
Yeah, well.
There we go.
I shouldn't talk too loudly. They play each other this weekend. You and I aren't going to get along this week.
Well, yeah, but where's that at?
Chicago.
Well, Chicago hasn't won at home yet, so
Well,
you're probably safe.
The Vikings are coming down, so that means they'll finally win one at home. Okay, undo addition or subtraction. So obviously, what's the last one going to be, guys? Undo multiplication or what? Okay, so do you guys have the rules down? You guys have the rules down? One. Good enough. Forget the X question mark, okay? I try. What's one of the favorite sayings? It's better to try and fail than do nothing at all. Alright, so I tried. Guys, okay on the rules? Do you have the rules down, number 1? That's my first question.
Yes.
Okay. Hey, let's look at an example here that would involve inequalities and all the rules that might come into play here, alright? How about volunteer to read example 1 for me? I want to volunteer to read example 1. Thanks, Allie.
You are participating in a charity walk. You want to raise at least $500 for the charity. You already have $175 by asking people to pledge $25 each. How many more 25 pledges do you need?
How many more pledges do we need, right? Okay. Here's the deal. How much money do I have already? How much money do I have already? I have 175. We'd like to make at least how much? If I say I at least make 500, I'm going to give some values and tell me if this is going to work. Would $400 be enough? No. Would 500 be enough?
Yes.
Yes. How about 600? So it sounds like to me you're telling me we want $500 or what? More. Okay. Let's set up a verbal model for this. Okay. We already have $175. So the amount that we have, we're going to add to it some more pledges, and each pledge is how much? If I walk up to Maddie and say, Maddie, this is our foundation. We're trying to raise money for a charity right here. Pledges are $25 a piece. How much money am I trying to get her to fork over to this? $25, okay? So we have some money, and to that we're going to add some more $25 per pledge, right? We said we want all of this money that we have plus the $25 pledges that we're still going to go out and get. We want that money to be at least $500. You guys told me that it had to be $500 or what? more. So I want this part right here to be either greater than or equal to what value on the right? Well, $500, right? Okay, are you guys with me on that setup? Does the verbal model there I have make sense? We have some money. We have some money right here. We're going to add some more pledges. We don't know how many, but each pledge is how much? $25. By the time we get all done with this, we want what's on the left here to exceed or be at least $500. Okay? So let's fill in some values that we know. What did you guys tell me we had value-wise already? Okay, so where I have this word have up here, how much money do I have? The dollars that we have? Okay. We already have $175, right? To that, we're adding $25 per pledge, keeping in mind that right here it says how many more pledges do you need right there, right? How many more pledges do you need? Well, do I know how many I need right away? That's what we're trying to solve for, right? If we don't know, we're probably going to use a variable for the number of pledges, aren't we? How about my favorite letter of the alphabet? How about $25 times P? Doesn't this mean $25 times the number of pledges that we're going to add to this right here? So if P was 10, we would be adding 25 times 10, right? If P was 50, we'd be adding 25 times 50. Okay? Well, that's going to be greater than or equal to 500. All right, so let's apply our rules that we have from solving equations into multi-step inequalities. All right? You may not like the way that this is set up. I might rewrite this as 25P plus what first? Whoops. Can I write it this way first? Just switch these two around, still greater than or equal to 500. Let me ask some questions. Any parentheses to get rid of by rule 1? Any distributing to do? Yes or no? No. Do I need to combine terms on the left side or the right side at all? Answer is what? No. All right? Do I have variables on one side or two sides right now?
Two sides.
Careful. Just have the variable on the one side. That's a good deal. So now I'm at that point. Undo addition or subtraction. Any addition to take care of to isolate P. So subtract the 175, right, Taryn? Okay, so help me with this. What are the 175s doing to each other on the left? Gone. So I have 25P greater than or equal to, somebody help me, 500 minus 175, what is that? 325, right? Guys, keep in mind, if I ever add or subtract values, does that ever switch this inequality sign at all? Not under addition or subtraction. Now, when we get to this part, it says undo multiplication or division. The only time you would flip that is if you were multiplying or dividing by what kind of a value? A negative. Okay, so let me make a little room here quickly. All right, let's finish this up. What am I going to do to finish this up? Divide by 25. All right. Somebody take 325 and divide it by 25 for me. Tell me what you've got. 13. So I have P is greater than or equal to 13. All right. So let's bring this all together. What the heck did the P even mean, guys? What were we trying to solve for up here in the highlighted part? Number of pledges we can see. This is saying P has to be greater than or equal to what? Is it okay for me to come down here and tie this up by saying this P greater than or equal 13 represents that we need, I can have 13 or what? More. So could I say at least 13 pledges? At the very least, we need 13 pledges. So we need at least 13 pledges. Ooh, boy, this hurts. Set, go. All right, that example makes sense to you? You guys have that down? All right, let's look at some examples. Let's kind of grind through this a little bit. I know that there's people that say, I'm not real sure on the multiplication division part. Everything I'm talking about here is kind of a a branch off of the things we've been doing. So if I didn't get stuff today, you got a few things to polish up. At least pay attention to, again, what we're doing. This is kind of a review on things where we're at. So, hold it just a second. I'll get to page 2 here quickly. You guys have that all down? Let's jump over here and look at some examples. I have good news.
What?
We're at the end of chapter 3.
And you would know?
That would be followed by bad news.
Oh, it's even better news. You have the opportunity to improve grades, Mrs. Miller.
Oh.
Glass is half full today. Let's start with this one right here as an inequality to work with. We have 2x plus 9 less than 25. All right? You know what? Give me a volunteer. Just start me out. Where do you want to go first? Where do you help, Taryn?
Subtract 9.
Okay, we're going to start over here. We're going to help out the 9 first, right? Okay. Everybody agree? All right. Taryn, again, question. Will subtracting a value ever switch the inequality sign? Okay. And you know, Mrs. Miller brought up a good point yesterday. I'll kind of go with it here, but this idea of switching signs when you multiply or divide by a negative, maybe you want to go through all your problems first and just circle that sign that you know you've got to switch before you even get going into all problems. So here it looks like I'm going to be dividing by what kind of a 2 in the end? Positive. So if I divide by a positive 2 in the end right here, is that going to stay the same or switch? It should stay the same, shouldn't it? Okay, so Taryn, keep talking me through this, all right?
So then you divide by...
Okay, well, let me rewrite this. I'm sorry. I'm behind you. I'm slowpoke today. This would be 2x is less than 16, right?
Yeah.
Okay.
And then
Divide
divide 2 on both sides.
by 2 on both sides. Good. And 2's will cancel, so we'll have x less than 8. And again, don't change that sign again because we divided by a positive, right?
Are we supposed to graph these ones?
I was just going to go there real quickly. Part of your assignment sometimes say, hey, what would this look like graphically? Give me 1 second. I'll fix this for you. Let's see what this would kind of look like here. So graphically, what would this look like? Well, if I had a number line that looked like this, if this was my number line, okay, I'd reference 8. Would you be open or closed on 8, gang? Open. Okay. Give me a number that's going to work in this solution, x less than 8. 2. Where's 2 going to lie in relationship to our reference value of 8? It's going to lie to the left here, so I'm going to shade to the left. Okay. Make sense? And I think part of your problems the other day were like, okay, you got this inequality, now you got to take your solution and match it up with a given graph. Was that part of your assignment there? Okay. All right, let's try another one. Let's try another.
It's easy to tell which way you're supposed to shade it because depending on which way your left side or equal to side.
Taryn, I like that idea. I will always tell you to be very, very careful. It only works if the variable's on the left side. Because if I switch that around, okay. Question, Allie? On which one?
Why can't we solve for x?
Why can't we did solve for x? It's here.
Well, x equals 16 divided by 2, and then x is 8.
Right, that's this part right here, right? And then don't the 2's cancel on the left right here? So what I've done is take this whole thing right here and just simplify it to x is less than 8. Are you wanting to put an equal sign in there? Huh? How come? Because you're used to it? Let me ask you this question. Was there an equal sign in the original problem at all? So if it's not there in the original problem, will that exist in the end here? Won't, will it? Okay. Let's try another one. I think we'll catch on here, all right? All right. This would be a good one to go good one to look at. All right, 14 greater than or equal to x over 4 minus 8. Now, we can do a couple things with this. We can start working with it as it is, or I could choose to rewrite this. How many of you guys like the way it's set up with x being on the right side? Nobody likes that. How many do not like it the way it's set up? Okay, Lily, you have your hand up. Why don't you like this? Other than the fact that you just don't like it.
It just looks confusing.
Looks confusing because x is on which side? On the right side, right? We'd like to have it where? Can I take what's on the left and move it over here and take what's on the right and move it? Okay? Well, let's do that. Let's just rewrite this. I'm going to rewrite this in red. So let's rewrite this. Let's just see what I do. Okay. Guys, up here in the corner. If I had 3 and 2 as a comparison, how would 3 relate to 2? Isn't that bigger than 2? So if I would switch the 2 and the 3 around, which I can do, what would be the sign that would go in there now? Wouldn't that be a less than right there? So if I switch what's on the left with what's on the right, what do I have to do with the inequality sign as well when I rewrite them? Would you have to switch them? Okay, so let's rewrite this. I'm going to call this x divided by 4 minus 8 first. All right, and then over on the right, I'm going to put the 14. Now, guys, my sign originally was greater than or equal to, wasn't it? Everybody agree?
Yeah.
Everybody agree there?
Yeah.
So since I'm rewriting it so x is on the left-hand side, what have I got to do now? Switch that sign to less than or equal to. All right? Lily, is that what you were wanting to do with that? Okay, so my next step, somebody shouted out, in solving for my values of x that will make this inequality true. Plus 8 to both sides. Boom. All right, now what? Don't I have x over 4 here? X divided by 4, less than or equal to, what's 14 plus 8? 22, right?
I'm so far behind. 20.
Now it says x divided by 4. What are you going to do to both sides now? Times by 4. Since I'm multiplying by a positive 4, will I switch this or not? Nope. Multiply by 4. And what's going to happen here and here? Well, those are gone. This will be x less than or equal to, how about the product of 22 and 4? 88. All right, so there's your solution to this one right here. All right? Guys, really, this is the same thing as solving equations. We just have a couple special rules that apply to inequalities, don't we? Same exact thing as equations. We just have some rules to apply to inequalities, all right? 3 and 4. Move that up so we can still see it. We need to get down. All right, let's get tricky. You guys ready to get tricky? You guys alive today? Teaching a bunch of zombies, huh?
Yep.
Awesome. Knew I could that. Knew it. Knew it. I got to walk now. All right. Hey, are there parentheses in this column? Okay. Yeah. Gotta distribute first, right? All right. Help me out, gang. Negative 2 times 3x. What is that? Negative 6x, right? Okay, I've got a negative 2 times a positive 6 here at this point then as well, right? Which is my, what's that value? Oh, come on. Negative 2 times positive 6? Negative 12, right? Less than or equal to 28. Okay, what's the next stepper?
You add 12.
Add 12. Let me do that. Plus 12. Plus 12.
Yes, please.
Okay. Left side, I have negative 6x. What sign am I bringing down?
Less than.
Yes, less than or equal to. This will be 40. Okay. Now, be careful on this next step. Very, very careful on this next step. In my process of solving, all of a sudden, we're going to choose to divide by what kind of a value? And divide by negative 6, right? Okay. Alrighty, I get that these cancel. But what's going to happen right here now since you divided by a negative? Other direction, right? Dividing by a negative, we're going to go greater than or equal to. Alright, 40 divided by negative 6, that's kind of ugly, so I'll just show you what I get here. 40 divided by negative 6. Ooh, lots of 6s, huh? How about negative 6.6 repeating? Is that okay? Okay. Alright, so there you have it. X is greater than or equal to negative 6.6 repeating. Alright. Okay, let's try one more together, and then I'll give you a chance to try a couple. Again, book assignment not due until when? Thursday, all right? All right, I'll try and make this as painless as possible. Okay, what's kind of tricky about this to begin with? We haven't looked at an example like this yet, so I mean we've talked about the scenario as it relates to equations before, but what is it about this that's kind of difficult? Set of variables on one side, they're on both sides. Good, all right? So give me thoughts on how you might start this. Bill, got an idea? I want variables on both sides. I guess that's a better question to ask. I want variables on both sides? No, I'd like to have them all on the left, right? So since there's a 4x on the right, we probably better get rid of that. You guys agree? Okay, so what kind of 4x is that, kiddos? Yeah, so we got to subtract 4x. So let's do that. Again, keeping in mind addition and subtraction will never affect the sign of an inequality. So help me combine some stuff here. 8x minus 4x. Where are you, game? 4x, right? I'm going to run out of room here, it looks like, so I'll try and make a little. There we go. What's going to happen on the right side? So I'm still greater than 18, right? Guys buy that? Okay, so now it's just two-step. We're add how much at this point? Down to 6. You're going to have 4x greater than 24 here. Okay, so my final step. When you're at 4x is greater than 24, what are you going to divide by now? 4. Sign going to switch or stay the same? Stay the same. You're dividing by a positive. So what's my solution going to look like when you divide by both sides by 4? What's my final solution going to look like? You have to have a variable sign and a value. X is greater than 6 as a solution. Very good. All right, so I know there's a lot going on here, but guys, I got to be honest with you. Really, exact same thing as equations. The only time you're really switching these signs right here is if you would switch what's on the left with what's on the right before you start from, or in other words, rewriting it, or if you're multiplying or dividing by a negative. Okay, guys, every single one of my answers here, here, and here always had a variable, a sign, and a value, didn't it? Variable sign value. Alright? Give me a number down here that would work in that original inequality. What numbers would work for this inequality up here? 10 would work. Would 19 work? How about negative 2? Would negative 2 be a solution to this? No, it wouldn't. Negative 2 is not greater than 6. Alright. Everybody have that first of all? Okay. I'm going to give you guys about 5 minutes here. What I'd like you to do is jump over to the on your own. Okay? Might want to partner up with somebody on these and work your way through them. Don't do this third one right here. We'll do this one together. So save this third one right here, and we'll do that together. But give those 3 a shot on your own, all right? See what you come up with. Don't forget, your solutions have to have some kind of a variable, some kind of an inequality sign, and a value. 3 parts to your answer, right? If you get stuck, check with someone around you, talk through it. Again, like I always tell you, if you get done early and you're looking to compare answers, check with a neighbor. If you disagree, talk about why you disagree then, okay? She is absent today. I have an email already in from Kenda this morning about sending work home. So I'll make sure. I'm just going to email Mom and tell her to watch the lesson online. I'll just email the assignment to her. So check this one. Good luck, kiddo. Good job. Is that the one hang up you're having, Alan? Just which way the sign's going sometimes? What are the rules for switching that sign? Tell me what the switch is multiplier divided by negative or this right here. So x on this side of the sign, so we'll take the x to maybe 3 years since I switched to bigger than switch this up. Sure. Because I'm going to do something with this one up here. Billy, you got a question? Or are you done? Leave me hanging here? My gosh. Yeah. Negative 6. Alright, guys, I want to try and get some time to you. Do a short, quick quiz in here today. So, done or not, looks like you guys made some really good progress on most of these. How about a volunteer to go up for the first one here? Taryn, you said you on the first one. Alright, Taryn. Talk me through this, okay? Talk to me like I just walked into Union High School today. I've never been here. Talk to me about what it is that you're doing today. So explain your process is what I'm really asking you to do.
Okay, so I'm gonna take negative 1 of both sides.
Okay?
And then which one gets left?
Those are one of the examples I did.
Yeah.
Oh my goodness, I didn't have any idea.
Yeah.
That's all right.
See if they're paying attention.
2x.
You will look. I agree. I totally agree. You're right on track, Terry. Good job. Everybody agree so far? Yep. Okay.
25 minus minus 16. And then we divide by 2.
Divide by 2. All right. she's got up there, x less than 8. Excellent, all right. Just kind of talking about the second problem up there. Do you guys understand why I rewrote that? I don't like having x on the right side. I like to have it on the left. Okay. Now, when I switch what's on the right side with what's on the left side, greater than or equal to had to switch to be less than or equal to. Do I have a volunteer that would be willing to tackle that one? Want it, Lil? Lily's good. She's comfortable in her seat at home. Taryn, pick someone to do that one. Make you the bad person. Timmy Mac? Tim, you want it?
Nope.
Kyle, you want it?
Good.
No. Mrs. Miller, you want it?
No,
How
but
about-
John,
how about
John, what
Jones?
are you doing?
John, you want it?
John?
Which
You
one?
wanna
This
go
is
up and give
right
that a
here.
shot?
Can I bring my paper up?
You sure
Like
can.
that.
Did you rewrite it first, John?
Yes.
Awesome. Is the pen still up there, Taryn?
Yeah.
Okay.
You better. Or you'll be hearing from my lawyer. Just kidding. Let's see, was it like this one?
Yep.
Yeah, hey, John, do me a favor. Do you see the scroll bar on the bottom?
Yep. Scroll it.
Might want to slide to the right a bit. There you go. All right, that should be good.
Okay.
That come from the chair.
I don't know, it's on the floor now.
Okay.
Okay.
All right, John, talk me through this. I've already rewritten it. Looks
Okay.
like you have too, so carry on, buddy.
We had both. We had -2.
So what are you going to do to get rid of that -2?
I had 2.
All right.
Like so. -1, right?
Excellent.
Four. Now, we would multiply by 4 right
All
here.
right, let's hold on 1 second. I want to clean a couple things up.
Yes,
Draw a line under your left side.
like this.
Yep. Just, yep.
Connect it like this.
Yep. And there you go. Now, what do you still have on the left side? Don't you have x over -4?
Yes.
So, under that line to the left, write x over -4.
Okay.
And between your two expressions, you still have the sign less than or equal to, right?
Yes.
Put a less than or equal to in there as well.
Like that.
Yep. There you go. All right. See why I did that? I want to
Yes.
keep everything balanced. Okay. Now what's your next step? You were telling me what you were doing next.
Multiply -4 on both sides.
Good. See if he gets by this tricky part.
Can you read that?
Yeah.
You told us what we did, you bet. And if you want to overlap a little bit, that's fine.
Okay.
So you did it to the left.
Okay. Which is +4.
Okay.
Now, x would be greater than or equal to,
Why greater than or equal to, Johnny?
because we have to flip the sign.
Why do you have to flip the sign?
Because we multiply by a negative number.
Awesome. Good work, kiddo.
Okay. Now, who do I pick?
How many x is greater than or equal to 4 there? Very good. Okay. Who wants that bottom right one down there?
I think Maddie should.
Maddie, are you willing?
No.
Even if I talk you through it? Chelsea, you want to help us out?
You're welcome.
Thank you. Good job, John. Give Miller a high five and say, what do you think about that?
Yep.
Alright, so you're distributing first, it looks like. Is that right, Chelsea?
Yeah.
Okay.
We're gonna move this down.
Here you go. Okay, added 21 to both sides, I agree. Now you're dividing both sides by -3. Oh, let's see. Did you divide both sides by -3 there? second question I have for you. What kind of 3 did you divide by again?
Negative.
Negative. Divided by a negative, right? So you want that to be greater than or equal to, okay? You see the little blue loopy arrow up there? First of all, can you reach that?
Where?
Way, way up top.
It's like an undo button.
Undo.
Right here?
Yeah, that one. Can you reach it? Do a few undos. More. Stop. All right. Divide by -3 on both sides again. Okay.
Now,
And do it to the left side also.
right here?
The
Or
left side.
Yeah, your other
There.
Chelsea.
There you go. There. Good. That's what I want to see. X is greater than or equal to 2. Very good. All right. That's nice job. Okay. I kind of wanted to talk about what's going on in this last one here. I don't know if we're going to get through the quiz today, and that's fine. All right. We can save it for tomorrow. Guys, this last one right here is kind of tricky. 2 things. Number 1, do I even like where X is at? No. I'm going to rewrite this. I'm going to call this -4 minus X. Put that on the left. I'm going to put my 2 on the right. Okay, since I did that, what do I have to do right here then? Okay, so this will be a less than, right? Okay. Now, the tricky part about something like this is the following. I don't even like where X is at on the left side, so I'm going to rewrite this as -X minus 4, still less than 2. You guys agree that I still have the same thing?
Yes.
How many negative X's is this right here, though, gang? Negative how many? -1X, right? All agree? All right, so if I'm going to go ahead and process my way through this, I'd have to add how much here? Okay, so I've got -1X less than, what is the 2 plus 4 on the right? 6. Last step then, I've got to get X to be all alone by itself. I'm going to divide both sides by -1. Therefore, what's my solution going to look like when I divide by -1? Yep.
X
Less than or greater than?
greater than,
Why greater than, Timmy?
because it's going towards a bigger number.
Well, that, but what's the rule? What's going on process-wise right here?
Negative number.
Divided by a negative, good. All right, what is 6 divided by -1? 6, okay? All right, hey, you guys did a really good job at this, all right? Now, here's what I'm going to tell you. If you didn't get the stuff turned into me today, try and get it to me by the end of the day. If not today, I need it first thing tomorrow morning, okay? I'll bounce back up to here. First of all, you guys, did you get all that written down? Johnny, you got it?
Yeah.
Allie, go up a bit. Down. Good. Bounce back up here then. You guys know this book page that I gave you? Right here, not due until when? Thursday. Okay, a lot of stuff going on here, all right? Gonna have to show some work. Take your time with it. I think you'll be okay, all right? Okay, any questions for me at all today?